All right, so chapter 8, we're going to be dealing with linear equations and functions and relations. And to start out with, I just want to get kind of a knowledge of some of the terminology that we'll be using a lot. So, and a relation is just simply a set of ordered pairs. So they can be given to you just in parentheses and like a long line. They can be given to you in a table. They can be given to you on a graph. Doesn't matter how they're delivered to you, but it's just kind of, it's very generic. It's just a set of ordered pairs. And as a reminder, an ordered pair is an XY coordinate. So we're going to be talking a lot about the XY coordinate plane, and each point has kind of an address, and that address is the X and the Y coordinate. And so each one of those XYs is called an ordered pair. Okay. A function gets a little bit more specific. A function is a relation where each X only has one Y. And that's not going to make a whole lot of sense until we get into actually showing you how to see that. But when you have a relation, that's just a bunch of ordered pairs, then you got to look a little bit closer and say, is this relation a function? And the way we do that is we look at the X's and we see, are there any X's that repeat? So do you have like an X of 3 listed twice? And that X of 3 might go with a Y of 2 and a Y of 5. That's when it becomes not a function. If you have that repeating X, I jokingly call it the cheating X. I'll have you guys write that on your paper here in just a minute. And it just kind of makes it a very simple test, kind of a silly memory trick way of remembering whether or not something is a function. All right, so when you have an X and a Y coordinate, or if you have an X and a Y as part of your ordered pair, one is considered the dependent and one is considered the independent variable. So go ahead and I'll erase some of this because we're not there yet. This is from first hour. But I want you to write what I have there so far. Slide it up a little bit. We have an independent variable and a dependent variable. All right, so what does that mean? Well, what I equate it to is a Hershey Kiss factory. So if you go to a Hershey Kiss factory and you kind of walk through the plant, see how the process is made, you're going to start out at the beginning with all of the ingredients, the cocoa, the butter, the sugar, the cream, all the yummy stuff that goes into making a Hershey Kiss, right? It all gets dumped into the machine at various places. It runs through the machine. And then out on the other end of the machine is the conveyor belt that's bringing out all the little Hershey Kisses or the finished product, right? They wrap them up and they send them out. That is what a function does. A function is a machine or an equation that when you input an X value, it's going to spit out a Y value. So the input are your ingredients, right? Or your independent variable that is just the data given to you. So if we have an equation that looks like this, okay, that's a function. Now, the way it's written right now would be called an equation. This would be called a function. And I want you guys to realize and see that these are the exact same thing. When you see f of x, and I want you all to do this, I want you to draw an arrow to the f of x, and I want you to write the word fancy y. Because that's all it is. It's a fancy math notation for the y, okay? So y equals 2x plus 3, and f of x equals 2x plus 3. Means the same thing. It means that if I give you the ingredients or the input or the X value, you can put it into the machine or into the function, do all the math, and it's going to spit out the Y. So if I give you that F of 3, okay, that means that in my function, I want you to input the ingredients 3. So you would put 2, and then where there's an X, you would put a 3. So notice I took my y equals 2x plus 3, and in place of the x, I put the 3 because that's the ingredients that I was told to put into it. Okay, so now when I work it, 2 times 3 is 6, plus 3 equals 9. So my input was a 3. My output or my result when I ran that 3 through the equation was a 9. So my ordered pair that this produces is 3, 9, because 3 and 9 are kind of bound together, because in this function, when I input a 3, it outputs a 9. If I were to input a 5, I'd get an output of 13, right? If I input 10, whatever input you put in is going to change the output. And that's why the input is called the independent variable, because it's just data I'm giving you. And then when you run that through the machine, it spits out the output or the solution. Okay, make sense? That's just a little bit of foundation we're laying, and then we'll kind of build on that all through chapter 8. All right, so first thing we want to do in section 8.1 is we want to determine whether or not all these relations are actually functions. We know they're relations because relations are just a set of ordered pairs, but our directions here say determine whether or not each relation is a function. And then it says explain. Okay, now again, you guys know, right? I teach math, I don't like words. So your explanation is not going to have to be words. I'll show you what I mean here in just a second. But it's just going to have to be, you're just going to have to explain to me why you don't think it is a function. Okay, so how do we know? Well, think back to our definition of a function was that it's a function if each x only has one y. So how do you find that out? Well, first thing is you have to just look at your x's. So I'm going to highlight my x's. I've got a 4, a 0, a 1, and a 7. Do I have any repeating x's? Nope. So each x is just a single x by itself that just has a single y, right? So does that match the definition of a function? So would this in fact be a function? You just have to write yes. No explanation needed for yes. So a couple things I want you to write in on your paper as just some helpful hints as you're doing your homework. One is explanation, put only if no. You only have to explain if your answer is no. If your answer is yes, you do not need to write out a big lengthy explanation. The other thing I want you to write, and this is just a silly memory trick, okay, is, let's see, a function is if there are no cheating x's. No cheating x's. That is your only test you have to pass when you're given a relation. So in number 1, we didn't have any cheating x's because we didn't have any x's that repeated, right? 4, 0, 1, and 7. Every x had a y. So it's a function. Now look at number 2. Just look at your x's. Y's can do whatever they want. It does not matter what the y does. So if I just look at my x's, I have a 5, a -2, a -7, a 1, a 4, and a -7. Do I have a repeating x? Yes. Okay, which x is it? -7. All right, what is -7 doing? -7 is a cheating x. Why? Because -7 is with the 15 and with the 2. So it's a cheating x, which means, is this a function? Nope. Yes.
So does that mean like if the x's are the same and they have the same y's, that's good?
It'd be fine because it would basically be the same point. So yeah. And I don't know that you'll actually come up on that, but yes, it would be fine. You just can't have a cheating one. You can't have one x that goes to 2 different y's. The y's can do whatever they want. You can have a y go out to 10 different x's and it doesn't matter. All that matters is you can't have any cheating x's. So here's what I mean by when I say explain, only if it's a no, and no words needed, okay? You don't need to write out an explanation. All I want to know is who's the cheating x. So no, it's not a function because of x equals -7. So the only explanation needed is when it's a no, and the only thing you have to tell me is tell me who the cheating X is. Yes,
So if the Y's are the same. Yes.
right, because Y's can do whatever they want. Yep. All right, so let's look at number 3. Just look at your X's, that's all that matters. We've got -3, 3.5, 4.1, -3, and 3.4. Do we have a repeat? Yep, we've got that -3, and -3 is a cheating X because, whoops, -3 is with, meant to go with my pencil, -3 is with 4.2 and we're 3.7. So it's a cheating X. So that means no, it is not a function. Since your answer is no, tell me why. Why is just simply list your cheating X. These really are super simple if you just remember the no cheating X's. Okay, all right, let's look at number 4. Only thing you care about is your X's. So we've got 7, 14, 11, -10, -1. Any repeats? So am I a function? No need to explain. The answer is just yes. And an answer, Colton, to your question earlier, look at the Y's. Look at -3, right? The Y of -3 is repeated and it goes out to 2 different X's. That doesn't matter. Y's can do whatever they want. Okay? We good with that? All right, that is when you are given the data in either like a line of parentheses like 1 and 2, or in a table like 3 and 4. And sometimes, and I just want to point this out, sometimes your table might look like this. And that's okay too. Let's say our table is 3, 4, negative, whoa, that was a weird way. -2, 3, 4, 6, 6, 6. Would this be a function?
No.
Why? That's right. This would, the 6's are fine. The Y of 6 doesn't matter. What made this not a function is right here, my cheating X. Okay, X of 3 went out to 2 different Y's, so it's a no. Okay, why is it a no? Here's your explanation. All right, are we good there? So given a relation, right, you can be given it as ordered pairs. It's not, it's written, but it's not, it looks weird, but this is an ordered pair. This is an ordered pair, right? That's an ordered pair. They're just stacked on top of each other. If it's an up and down graph, this is an ordered pair. This is an ordered pair. So you can be given the data of a relation in a bunch of different ways. No matter how it's given to you, you still use the cheating X test. Okay. All right. Now there's another test that's, I think, even easier than the cheating X test. And this is just because it's just visual. Okay. It's called the vertical line test. So out to the side, I want you guys to write vertical line test. And in the vertical line test, you take a ruler or a pencil or something, okay? And I'm going to do it on the screen, and then I'll do it on my iPad for those at home that are watching this that don't see what I'm doing on the screen. But you take a pencil or a ruler or your finger or whatever, okay, or just your eyeballs, and you ask yourself, does this pass what's called the vertical line test? Well, this is a vertical line go up and down, right? This is horizontal. This is vertical. I always think horizontal horizon. Okay, so if you I always have to say horizontal horizon every time before I remember which one's vertical and horizontal, but that's okay. So vertical lines go up and down. What it means to pass the vertical line test is when you put your vertical line anywhere on this graph, does it ever touch in 2 different places at one time? And here's what I mean. This is your x-axis right here. So we're still looking for cheating x's, but we're doing it in a little bit different way. If I put my ruler right here, okay? And actually, I think it's even easier, and I'll do this on the iPad too. If I've got this graph, and I've got it going like this, right? If I put my ruler right here, I touch here, and I touch here. Everybody see that? Well, if I were to name this point, it's kind of hard because I'm not. Okay, if I were to name this point right here, the X and the Y coordinate of this point would be 2, 3. Does everybody agree with that? What's the coordinate of this point? 2, -2. Everybody agree with that? What do I have? I have a cheating X. Because at the X equals 2, which on this graph would be right here, this is X equals 2. At X equals 2, it fails the vertical line test because it touches here and it touches up there. This one fails a lot, and you only take one failure. It only takes one failure to make it not a function. But this particular one fails in several places. What if I was to put it at X equals -1? Does it fail? It fails. X of 0, it fails. X of 1, it fails. And when I say it fails, it's because it touches and it touches. It fails at 2, at 3, at 4, and really every X forever and ever, because the arrows tell you it goes forever and ever. Okay, so if you put a vertical line on your graph and run it from left to right, is there ever a point where you have one touch or a 2 touch and it can even touch 3 or 4 times? But if it, all it takes is one place where it touches at least twice for it to fail the vertical line test. Okay, so on this one, and I'll do this on my iPad so those at home could see what I was doing. If I were to put a vertical line, say right here, and this is at X of 1, right? It fails because it hits here and here, meaning that the X of 1 is a cheating X because it has a Y of 2 and it has a Y of not quite -2. So the answer here would be no, it is not a function. And as far as why, you might all have a different answer, right? Eli might put no because of X at -1, because does it fail at X of -1? It sure does. It fails right there. Blake might put X of 1. Sophia might put no because it fails at X equals 3. Well, does it fail at X equals 3, which is right here? Yep, it fails there too. So any one place where it fails is what you put on your answer as far as a no. And you only have to list one, okay? I put 2, just making the point that there can be different answers. But you only have to list one failure spot for it not to be a function, okay? How about this one? If I take a vertical line and I put it, say here, I can try it here, I can try it here, all the way across my graph. I run a vertical line. Is there ever a point where I hit my graph more than once? I hit it here. On this one, I only hit it there. I only hit it there. Each vertical line I try only touches my graph one time. So does this pass the vertical line test?
Yes.
So it is a function. Okay. Now I want to show you on if you want to write these down on your notes, you can. I'm going to show you a couple of other examples of graphs that you might see. Okay. So how about if you've got, okay, this is your X and Y axis. Okay, here's your X axis. What if you have one that looks like, I'll do it in purple. What if I have a line that looks like this? Would this be considered a function? If I take my vertical line and I put it on that graph, there's a bunch of places where it fails. I'll just give you one example. Right here, it fails because it hits boom, boom, boom. So this would be a no, and I could put because of X equals 2, right? Because at X equals 2, it definitely fails the vertical line test. Are there other places you could put?
Yes.
You could put -4, -3, -2. You could put 1, 2. Does it fail here? No, but it doesn't matter. It only takes one failure to make it not a function. So yes, it passed the vertical line test on the green test, but it failed on the red test. And it would also fail on a blue test as well. Okay. How about if you're not given graphs, you're just given a bunch of points? Nope. You can't draw the line because you don't know how it connects. So what I mean by that is if I draw the line like this, does it pass the vertical line test? Okay, what if I draw the line like this? Okay, so if you're just given points, don't connect them. Just do the vertical line test on the points. So you're literally gonna try it at every point. Does it pass? Yes, because it only hits 1 point. Does it pass here? Yes. Here? Yes. Here? Yes. And here? Yes. So it only hit at 1 point on each. Now, what if I was to add a point right here? Yeah. If I was to add a point right here, then it would fail on the purple line. So you would, at this point, it would be no, and it would be because of x equals 2. Okay, but without that point I just added, the original way I wrote it, it does pass the vertical line test. Okay, now this is one I didn't actually talk about in first hour, and I had a lot of questions on it. I'm going to do 2 on 1 graph. Okay, first one I'm going to do is I'm going to do a purple one. This is my graph right here. Does that pass the vertical line test? Constantly, right? No matter where I put my line, it's only going to touch at one place. So the purple would be a yes. What if I have a line that is like this? That's at x equals, we'll call that x equals 4. Okay, that's a vertical line. Does that pass my vertical line test? That's like the ultimate failure. Why do I call that the ultimate failure? It literally is a vertical line. A vertical line fails the vertical line test epically. Okay, here's why. If I look at my purple one, I pass, I'm looking at my purple line. Nowhere do I ever have a double touch, right? If I try the vertical line test on my green line, it literally touches in a bazillion places, right? It is a vertical line. So everywhere I look, because if I were to identify, and I'll show you why, it still is the whole cheating X's idea, but we just don't have to name points in order to see it. If I were to name points on my green line, and obviously this is not a graph that's labeled, so I'm calling that X of 4, and I'll call this -4 on the Y-axis. So this point is named 4, -4. Everybody good with that? If I were to just randomly pick another point on this line and name it, I'll pick this point right here. That point would be 4, we'll call it 2. Everybody good with that? What's going to happen no matter where I put a line, or no matter where I put a point on this line, what's the X value going to be for every single one of them? It's going to be a 4 every single point I put on this line. Because no matter where I put, no matter how high or how low I go, the X is always going to be a 4, right? So I have the cheating X of 4. Like I said, an actual vertical line is like the most epic fail of a vertical line test you can have. Does that make sense? So this would be a no. Why? Because of X equals 4. Make sense? Okay. Another one we're going to do here, and then this will be the last thing we do. If you'll notice halfway down your homework, you're going to have to evaluate some functions. So we've kind of already done this. So this, I think when we did it earlier in the notes, when I was just kind of introducing the section, right here, we're given a function, right? And we're asked to evaluate each function at a given value. So what does that mean? Well, that means, first of all, where it says f of x, f is just its name. F, there's nothing special about the letter F. On your homework, you're going to see some that say g of x. I can have an h of x, a t of x, a p of x. It doesn't matter. That's just its function's name. So that way, like if I was in class and I was to say, Autumn, go up to the board, or Blake, go up to the board, by saying your name, you know which student I'm talking to, right? If I've got 3 functions on a piece of paper and I name them all f of x, and I tell you to look at f of x, are you going to know which one to look at? But if I have one that says f of x, one that says g of x, and one that says h of x, and I tell you to look at the one that says h of x, it's just its name. It just tells you which one it is. And remember, the f of x or the g of x or whatever is just a fancy what? It's fancy y, which means If I want to think about this equation in a much simpler way that doesn't make my brain hurt, I can rewrite it y equals 1/2 x plus 5, right? Now, if I was to tell you that, remember, this is the same as f of x. So that's telling me that the input or the ingredients that they want me to put into this function is a 24, right? I go back to my equation, and where there was an x, what am I going to put? I'm going to put the ingredients, right? So I'm going to put 24. So when you're asked to evaluate a function, they give you the ingredients, you plug the ingredients into the function, and then it's going to spit out a y. So that means that if I take 1/2 of 24, that's 12, and 12 plus 5 is 17. So f of 24, which means when I plug the ingredients 24 into my f function, it spits out the value 17. Okay, number 9, you work it the same way. Remember, this is f of x, right? Equals 1/2 x plus 5. That's my f function. So this tells me my ingredients is 11. So that means I take 1/2 of my ingredients, which is my input. And now it wants to know what's the y value when I plug in an 11. Well, 1/2 of 11 is 5.5, and 5.5 plus 5 is 10.5. So my function's value when I plug in 11 is 10.5. And you have to remember PEMDAS, so you do multiplication before addition. So I do multiply the 1/2 times 11 before I add the 5, okay? What if my input is a -10? It doesn't change anything. And if it helps you to write this every time, okay, it doesn't take but a second to do it. Again, f of x, this is your input or your ingredients to put everywhere where there's an x in the equation. So that means -10 plus 5, because it's telling me to plug -10 into my function. 1/2 of -10 is -5. -5 plus 5 is 0. So the value of my function at -10 is 0. Okay, I'm not going to worry about the bottom half of these notes because this isn't something that's on your homework. On your homework, I will tell you, and I'll just do this down here just to show you. On your homework, you're going to have f of x equals 4x minus 2, and then you're going to have g of x equals 3x plus 6. It doesn't matter. They're all fancy y's. It's just, f of x means that you're going to use that with anything that says f of 3. And g of x, you're going to use that equation. So over here to the side, if I was to say evaluate g of 3, which one of those would you use? The f of x or the g of x? The g, because I want to know g of 3, so you're going to use the g. If I tell you what is f of 4, which one are you going to use? You're going to use the f one because it's called f. So you just match the names. Yes.
I didn't get like the final answer
For number 9, there we go. 1/2 of 11 is 5.5, and then 5.5 plus 5 is 10.5. So 4 functions. F of something just means f of x. X is always your ingredients. So if it tells you f of 11, that's wanting you to plug 11 in for the x as your ingredients and then spit out a coordinating y. Sound good? All right. On your homework, I have already blotted out or whited out the ones I want you to skip. So all the ones left on your homework are the ones for you to do. And for those of you at home, if you have any questions, shoot me an email.